Why is sine squared plus cosine squared equal to 1? Let's talk about it. The Pythagorean theorem says that in a right triangle, a squared plus b squared will equal c squared. And if we call this angle down here theta, relative to that angle theta, a is the opposite, b is the adjacent, and c would be the hypotenuse. And so we can update our formula to say opposite squared plus adjacent squared equals hypotenuse squared. Let's divide everything by a hypotenuse squared. This on the right is just going to change into 1. And for each of these, we can take the squared out and make it just a single squared. And if you know SOHCAHTOA, sine is opposite over hypotenuse. So this opposite over hypotenuse right here is sine. And cosine is adjacent over hypotenuse. And so this adjacent over hypotenuse is cosine. This last one is still 1. And that gives us sine theta squared plus cosine theta squared equals 1. And we're talking about sine theta squared. We typically write that as sine squared theta plus cosine squared theta. On a side note, if you're curious why we write it like this, we don't want to think it's the theta that's being squared, because that's a possibility as well. So when we write the 2 here, it's very clear it's the sine that's squared and not the theta. What about the other trig Pythag identities? These are fairly straightforward to derive. So if we write out sine squared plus cosine squared equals 1, divide everything by sine squared, then sine squared over sine squared is 1. Cosine squared over sine squared, well, cosine over sine is cotangent, so this is cotangent squared, and then 1 over sine squared is cosecant squared. And then to get the other one, divide everything by cosine squared. Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. And that's how to derive all the Pythag identities. You guys are awesome. Comment on what you'd like me to solve for next. I'll talk to you soon.